bonk. Right. So this is Oracle SQL for beginners. My name's Ken Ma. There's my email address if you want to contact me. And this is class 2 of the SQL course. There are 8 classes in the set. You can make payments via Google Pay, which I haven't set up yet, which is free, or PayPal. But don't worry about that at the moment. We'll do that later. And this class is being recorded. So this is class 2. In class 1 we covered the first 22 pages. So if I jump to page 22, we did the dual cable and we got as far as order by. And the other thing we did was we looked at the files in the SQL zip file, and we opened the SQL folder and we took ex1 retrieve and we dropped it in SQL developer like that. Not like that. Actually, it doesn't work unless you've got a query window open. So if I open the query window, actually for this course we can use 77 because we're not going to do anything else in the way of updates, so I don't really need to dish out users yet. There we go. Now I can drag it over. There we go. I can't get hold of it. Oh, come on. Gotcha. That's better. And if I look at the tables, I'm going to use 77. So you can connect two by just dropping down. Drop down the views that we looked at last time. It hasn't got any tables. I'll explain about tables and views later. So we're here in the notes. And the next thing I was going to look at was the order by clause. Morris, can you do me a favour and turn your microphone off? Could you do that, please? Because I'm gonna have to start this again because we don't need all this background noise. Right, this is Oracle SQL for beginners. My name's Ken Ma. That's my email address if you want to reach me. Don't worry about payment. We're going to do that later. I'm recording the session. This is session 2, class 2 of 8 classes. When we did last one, we got as far as page 22. So we're picking up this class, looking at the order by clause. The other thing we did in class 1 was we looked at the zip folder, at the unzip files in the SQL directory. There was an SQL directory and a file in there called ex1. Retrieve, we logged in to the cloud database as user 77 and then we pulled that file over there, dropped it in there so we could look at the examples, and we are now on line 113. The order by clause. Right. If you want to ask questions, you two, just turn your microphones on and ask. But please turn them off again afterwards because it keeps down the background noise. I don't have any background noise. The cat's asleep. So, order by. There's some examples here. We'll pull that from 132 up to 115. Copy that. I don't like to change the original file. I'll put it in here and mess about with it. Paste it in there. Actually, we can move this over a bit. Whoops, not like that. I didn't do that. No, that's better. Just moved it over a bit. See if I can pull it back a bit now. There we go. Okay. Say Lord. These are instance. This is just examples of what's in the tables. That shows you what's in the say Lord table. Now, these are in order because I loaded them in order into the database. Some databases you expect them to be in order. Oracle not. You can see what I mean if you look at products, because you might expect product to be in product ID order, but it's not. it's in the order that I loaded the data into the database. Now if you want to order it, order by goes normally at the end of a select statement. So your select statement starts with select things, usually comma separated column names, but there might be other things. Has to be followed by a from and a table, one or more tables. You can add a where clause, and the order by goes last, so there are other things we can put between where and order by, but order by takes as well, that is a parameter. What goes there? Columns. A column or columns, and by default it's ascending. So that has sorted the products where the cost is greater than 250 into order by in stock. If you want it descending, you put desk, DESC, and that's why that column isn't called DESC, because it would clash with a reserved word. So I put an R on the end, and that one gives you the same thing by the way around, highest to lowest. If you want to order by multiple columns like that, comma separated, and if you want ascending, well, it's a default, you can put ASC if you want. So this one does ascending order of in stock, and within that ascending order of cost. Actually, you can use Control and Enter to run the query. So within in stock there, going up, we've got cost going up. It's simple enough. There's a bit more on order by later on. The simple exercises here, looking at this one's looking at the films tables. So looking at film titles, I think we did these earlier if you've done the exercises, but without the order by clause. So it's the same thing with a sorted on. So cost descending on that one, data entries on that one. And like I said, you can do the exercises between classes, and if all goes to plan, there'll be another class on Sunday. Now, I said at the beginning of the last class that there are some things in 12C that don't work in 11G, and this is one of them. Top end queries. Now, to show you that it does work, what I'm going to do is connect to my VirtualBox database. So if I clear that first and get rid of that, and then find another screen somewhere where I can start up VirtualBox. Let's shrink that. Now if you haven't done this, and you want to, if you look at the file in the zip file, the zip file has got in it a notes folder, and in the notes folder is this thing, and that tells you how to import a VirtualBox appliance, which is a fully fledged Linux, Oracle Linux I think it is, running an Oracle 19C database, which is the latest release from Oracle. So what you need to do is download VirtualBox, make sure you've got developer, and then you can download the appliance there. It's about 8 gig, but it expands to 25 gig when you install it. So all you do is open the VirtualBox software and import the appliance. It's very simple to do, and I've got a video on how to set it up afterwards. So if I want to set it up, if I go back to screen 3 here, there's my appliance there. It's called Oracle DB Developer, and if I start it up, it's already started, so it just comes up. You don't need that while it's running. It just comes up. It logs itself into Linux with the username Oracle and the password Oracle, and it starts up the database. And all you need to connect to it, username, password, port and SID, is an IP address. Now what I've found is when I do this, it tends to change the IP address. The IP address on my local network there is 192.168.1.88. I can find that was the last time I ran it, because this has been restored from the last session. If I run, can't do it like that. If I run IP space A, I can see what it's currently set to, because what I found is it flip-flops between 88 and 89. It's still actually 88, which is good. So I can connect to this, whoops, back here by using my user, which is user 1, a VirtualBox. If you've got your own VirtualBox, we can all use user 1. Make sure that's 88. It's different to user 77, if you remember, but because user 77 is an 11G database, it uses a SID of XE and its own port. 12C, 18C, 19C, they don't use a SID, they use a service name which defaults to ORCL, and that's the default port as well, 1521. So if I test that, and this is quicker than the cloud database because it's running here on my laptop, I can save that and connect. And this has got the same contents really as user 77, but rather than having views, this has got real tables. The views are just a read-only way of giving you a database access, because I didn't want everyone in the same database. We don't want everybody altering the data. I don't have a query window. I can open a query window from there. There we go. And then we can look at these top end queries now. Go back to retrieve and pull up top end query, which is there. You think it was easy, because it is in some other databases, just to find the top 5 most expensive products, but it's not. You have to use, with Oracle 11G, you have to use a subquery, a query within a query. But Oracle changed that at 12C, and they added this extension where you can say fetch the first 5 rows. So if you want the top 5 rows from here, and you only want the top 5 rows, you can add that line. Now normally an order by goes last. Oh, what's happening? It's not moving. Sorry, I'm typing, the cursor's not doing anything. Oh, brilliant. I think somebody wants to join. Chris. Chris, hello. 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 Nice to see you. Huh. Oh, part of it's my fault for confusing people over paying for things. I wasn't bothered about paying for things, and then a guy called Manith pointed out that PayPal's expensive. Well, not expensive, but you have to pay for it. So I tried to set up Google Pay today, but it didn't go very well. Whenever I open the app on my phone, it keeps telling me to add a card, but I've already added a card. It's got 2 cards in there. So I'm going to leave that for a minute, so don't worry about payment. Welcome here. We've got Jason and Morris from last week. I think we had Jason last week, did we? No, we didn't. What you need, Chris, is a new set of course notes. It's here in the chat. I'll just stop the recording for a minute. Oh, sorry, we had a blip in the video there, so we're starting again now. So what I was saying was, we've got this query that runs fine in 77, the cloud, but if I add the fetch statement, it won't let me do. What's the matter with it? My keyboard's got stuck. Don't understand that. I mean, it should run in this one. Doesn't make any difference to the keyboard, is it? I can't. My arrow keys won't work, and I can't go backspace or delete. Ah, dear. It works fine there. What I'm going to have to do is shut down developer for a minute. Right, bit of a glitch there, but it seems to have fixed itself. So I can say fetch the first 5 rows. That works. If you do that in oh, I've got 2 open here. How did that happen? Doesn't matter. Shut that one. Just to show you what happens if you if you try and do that in user 77 in the cloud, which is an 11G database. Wait a minute while it opens the database, winds itself up a bit. There we go, paste that there. Take that out, put the fetch first 5 rows in. And it doesn't work. There you go. So you can't do that. So this bit's only for 12C. There's another page with a few bits only for 12C, but these new things they put in, which are other databases just put top 5 in the select statement. You get the top 5 rows. I don't know why they didn't do that. They probably thought this was cleverer. So for instance, you can get the first 5 rows only. You can get the first 5 rows with ties. Is that American way of saying that they're equal to each other? That's what they seem to do. That's what their ties means. So only got 5 rows there. Now we get 6 rows because these have both got 500. And if you want percentages, this is quite useful if you're creating test data. You can say give me 50% of the rows in this table by just fetching a percentage. So that gives you 20%. There aren't many rows matching that. So that's, you know, that's top-end queries, but it only works in 12C. There is a way of doing a top-end query with a subquery that we'll look at later in 11G. Okay, so no exercises on that. I'm not going to use VirtualBox. I'll leave it running because I want to use the same thing you've got. Make sure it works okay. So go back there. The next thing I've got in this list is text and concatenate. Think about, I mean, the course does, it might seem a bit boring doing all these select statements, but you know, that's what SQL is. 90% of it is select statements, but then we'll go on and create tables, insert, update and delete the data. Then we'll look at joining tables together, and then you might find it a bit more interesting. Obviously it'd be more interesting if you were doing examples, especially if you're doing examples and the exercises. But it probably makes sense for this course to do the exercises after the course. If you come on the PLSQL course, which is programming, the programs build as you go through the course, so we won't be able to do that. You'll have to do the exercises on the course. It's not going to make sense, I don't think. So we've got here concatenation. If you run a query like that, which is what we did last week, which is the date from sysdate, the time from sysdate, you can put text in the select statement using single quotes, so that says the date is, and these fields are comma separated. And what you get if you run that is the date is today and the time. Now it's 3 fields because they're comma separated, but if you replace those commas with double pipes, what that does is concatenates or joins together the columns, so you only get one output like that, and that's today. And that's used a lot. That's quite useful. Now you can do this sort of thing. The word description, pick up the description, comma, the word cost, pick up the cost from the product table. And you get a list of products with descriptions and their cost. It's particularly useful for doing things like names from something like the employee table. If you look at the employee table, it's got first name and last name. I think if you look at the if we drop that down and we look at the views employee, there we are, it's got F name, L name. Member has got full names as name. So on this table you've got the full name, Alan Evans. So sometimes you want the first name or the second name. Now there are functions for doing that. Substring, for instance, you can pull out just the surname. Now on the employee table you've already got, which is neat, I suppose, the first name and the last name, but of course sometimes you want the full name. So to get the full name you have to concatenate first name with last name. And that's the exercise there. So you examine the data in the employee table, use the above syntax, because all the exercises follow on from something we've just done, to display the full name of each employee, the employee ID and their salary, ordered by surname. And then it says check that the data is correctly sorted, exclamation mark. I think you might find that some of these things, like Jan there, it's a lowercase j, so you might want to use something like the upper function to make sure it works properly. But anyway, you can look at those exercises, and if you've forgotten, the answers are in a file imaginatively called, why is that not coming back where it was? Because I've got a million, oh god, look what I've done, I've opened a million windows here. That's silly. Never mind. The file imaginatively named answers spelt backwards. That one. And the answers are all in there. So if you did the exercises from the first class, I know it's coming up with that. I should look into that. Maybe I should save the file as something else if it thinks it can't open it. But those are data retrieval. There's some of the things that we did last time as exercises, date exercises. Right. I haven't changed it, have I? Let's save it. Maybe it won't have an error in it then. Okay. It's very quiet. I'm sure you're still there. But do ask a question if you want to. You're in the employee table, and we will look at other things that you can put in a where clause. Such as in, between, like, and we're going to look at somewhere down here, a long way off, null values, but we start with in, between and like. We'll have those ones, we'll have in and between. And I copy that and paste it into here. Get rid of that, paste that, we'll drop that for now. So simple examples here. Find all rows from a supplier table where the town is York or the town is Leeds. Well, you can do that. We did that before, didn't we? Where town equals York or town equals Leeds. Case sensitive, single quotes around the literals. That works. But another way of doing it is you can say where town is in York or Leeds. And you do a comma separated list in parentheses for Jason or brackets for those over in England, same thing. Parentheses is harder to say. In parentheses. If you want to use numbers, yes you can, there. But if you're going to use numbers, don't put quotes around the numbers, because if you do, you're not matching like with like, you're matching a numeric field, cost, with a literal, and it will have to do a conversion, which is slower. So you don't need quotes around numbers, you do need quotes around character data. And you can say not. So if you want all the other rows there, I can say not in. It's like, it's not case sensitive. There we go, that gives me other suppliers. So there's an exercise on in. Actually, it's interesting that the number of values about, somebody asked on the course, what's the number of values that you can put there in that in list, and the limit is 1,000. But you can overcome that by using what's called a union or a subquery, and that's covered later in the course. That's quite neat, that. And you think, why would anyone put 1,000? But this guy who come on the course did. I think he used to paste them from an Excel spreadsheet and run the query against the database. So you've got simple queries, suppliers in Bracknell or Birmingham, films made in those 4 years, it says. Note that the film date made is a numeric field, it's not a date. And then you've got between here. So again, we're looking at the product table. Let's dump that bit. And we can say something like, give me those details from product where the cost is greater than or equal to 200 and less than or equal to 250. And you get a number of rows, I suppose. But another way of doing it is to say between 200 and 250. And if you want, you can say not between. What you can't do, which is annoying because it doesn't give you an error, is you can't say between 250 and 200. Well, you can, but you don't get any rows back, which is annoying because it should give you an error message saying put the 200 first. So it's lowest value, highest value, otherwise it doesn't work. Works like that. Those ones are fairly simple. There's list of films where the rental cost is between those values. Find all orders placed in the 2 months prior to the 1st of March. And same thing with the hint. What columns, what table, we're only looking at single tables, what restriction in the where clause, and can you make use of in between. Any questions? No? It's like a webinar, this. Thumbs up, that's what I like to see. My granddaughter does double thumbs up like that, and a smile usually. Right, it's eerie actually because your microphones are off because it kills the background noise, but it's deathly quiet. It's just me. You could all go home and I wouldn't. Actually, it might blip when you log out, I'm not sure, but I wouldn't know. I could be talking to no one. Thin air, never mind. We're recording it for God, we are still recording it, aren't we? Yep, we are still recording it. I keep thinking I've stopped it. I don't know if you Linux guys have done recordings. I'm using Simple Screen Recorder there. I tried a few others, but that one seems to work. It doesn't have the ability to show your camera, but you can use other things for that. Anyway, I don't bother. I don't need to be on the screen. Okay, this one's more interesting. This is the like operator. So we'll dump that, and we'll go back to retrieve, and we'll get the like examples, which are here. And copy that. I mean, if you're not typing along, that's fine, but if you want to type along the exercises, you know, the examples, I mean, there's no harm in doing that either. Entirely up to you. I did say I'd give you your own users for this class, but until we get to changing the data, you don't really need your own users. So I need to sort out the usernames. I mean, there are 25 users on here, but I need to make sure that then there's no overlapping, you know, everybody gets their own user. So I'll sort that out for next time. So what does like do? There's like. Like is it's a function. Not known as a function really. I always thought it was a relational operator. I know I posted this somewhere in a Facebook group and somebody pulled me up on it because he said it was a function, but that was a different function. I think it's a relational operator. So here you can say where description is like percent mouse percent, and what that gives you is these rows. That description's got mouse at the beginning, that one's got mouse in the middle, and that one's got mouse at the end. Now, the way like works, if you know what regular expressions are, and if you don't, we're going to cover them in a minute. Regular expressions allow you to write clever pattern matching. Well, pattern matching sets of characters. Like only works with 2 characters. Percent, which matches any number of characters including none, and underscore, which matches a single character. So when you say percent mouse percent, it says anything before the uppercase M, then mouse, then anything after the E. So that matches, begins with, contains, and ends with. If you change it and you say mouse percent, you get lines that begin with mouse. If you say mouse without percent on the end, you get lines that end with mouse. Like that. It all depends what you want to see. You can use regular expressions for the same sort of thing, as we'll see later on. Now this here is 4 underscores. 1, 2, 3, 4 there. So what that gives me is rows with 4 characters in the town, which is York and Bath. And then you can combine the 2 into this sort of thing. So underscore O percent is lines that begin with a character, then an O, then anything else. So you get iOmega, Logica, Kodak, mouse, first character, then an O, then anything else. It's like fuzzy matching in Linux and Unix if you use that. There's a couple of examples. There are products on the product table, which we could look at like that. Called Canon and Hewlett-Packard. So the exercise is to find all Canon products and order them by selling price ascending, and then find all Canon or Hewlett-Packard products that sell for over £200 and order that by selling price ascending as well. So now you're tackling what columns, what single table, what restrictions are where, do you need in, between or like, and do you need order by. There's more on like in a minute. Oh, stop there. That's interesting. See, when I used to do this in the classroom, we would do the whole section on select statements first. No, actually, that's not true. We would do this section on what is a relational database, the theory, with an exercise, and then we would do all of the select statement. I did the select statement first because I thought people coming on the free class would rather be writing queries than doing theory. So I split it. So there's another section which looks at queries coming up. So that looks at using the functions upper, looking at quotes, looking at escape character, something on regular expressions, something on nulls, and date comparisons. But what we'll do this bit next, I think, because it's something different. Get back over here. Now, it occurred to me actually that I hadn't shown you something when we did this. If I get rid of that and I open a new window for 77, what I didn't show you, this is the worksheet, was the query builder. If you don't know SQL, you can build a query in here. What you do is you pick a table. Now you have to know vaguely how things work. There's the order table and you drop it in there. That's the order table. Now if you know that there's a link between orders and sale lines, you can drop another table there and join them together. You say, well look, that column order ID is on this table, it's also on that table, we can make a link from there to there. And you can do this for the 4 tables, product and supplier included. And what it does, which is neat, it joins those tables together and it writes you a query in here. Now what I don't like about it is that's quite complicated. It's something that we're going to do later on. I'm going to explain how all that works. But if you run a query now, I don't think it's got any columns on it, has it? Yep, we've got all the columns. Didn't want all the columns. Suppose we go back there and we say we want the order ID, the supplier ID, the product ID and the quantity. What it'll do, it'll put those columns into this query here in worksheet. There. See what it does, it prefixes everything with a username. Well, if you're writing it, you wouldn't do that because that's the default. Generated stuff always goes over the top. So what you get is these details from these 2 tables joined together like that. Now that's a very simple entity relationship diagram, and this section looks at how you build these things. So we'll do that bit next, and we can get rid of some of these. We go back to the worksheet. I kill that and that. So this section looks at relational database and its components, the terms primary key, foreign key and index, referential integrity, and designing these diagrams. So it starts with gumph about the database. So if you've got stuff at home, you know, collection of DVDs, list of albums and tracks in iTunes, photos on a PC, you know, it's all the database. But real companies nowadays, they used to store stuff in filing cabinets. Now they store it on computers in databases. Computerized databases are very good at overcoming 2 problems you got with a filing cabinet. It's difficult to find a particular piece of information. If you live with someone, as I do, never puts anything back where it goes, it's impossible to find a piece of information. It's also difficult to rearrange the order of paper records. But databases are very good at finding a particular piece of information very quickly because they index the data and they're very good at sorting. So computer databases, you know, used by companies around the world, Oracle, SQL Server and MySQL are 3 of the most popular. So the relational database was invented in the late 1960s when Unix was being written, I suppose, and coming to the fore, by a bloke called Ted Codd, and he created a set of rules. I mean, most databases stick to the first 10 rules, I think, and at the time it was far from the dominant standard because we had things like network and hierarchical databases which were fiendishly difficult to reorder and change. The first relational database was released in the early 70s. It was picked up by Oracle, and by the early 1980s it became the standard way of storing data for most companies. The data was stored in tables, rows and columns. Rather than putting all the data together in a lump, you know, you split it into sets of tables as we have here. Now a particular piece of data such as the name and address, may only be stored at one table. I mean, that sounds obvious, but in some of these older databases, you did store the same thing in different places, and inevitably things got out of step. There should be no duplication of data in a relational database. Now, to see how this works, it says here, connect to SQL Developer. We've done that. Open the supplier table and look at the data tab. So if you want to run a query on the table, as I showed you last week, didn't mean to do that. If you want to run a query on the table like supplier, hold the mouse down and drop it there. Then you can say, I want a select statement, apply that, and you can run the query. Now, if you want to see the data rather than running a query, what you do is you click on it. Then it opens the data, and there's the data. We'll look at some of the other tabs later on when we've got tables to look at. So there's the data in the supplier table as far as credit rating over there. Actually, you can park this thing. Although I always have trouble getting it back. It ends up floating usually when I do this. Oh, come on. There we go. Then I can go back over there, probably never see it again. Whoops. Right. So that's what you get. And like I said, it's like a spreadsheet, rows and columns. Now, when you run a query and select a set of rows, what it does a sequential read through the data. So if you don't index the data and you're looking for the last row, it starts at the beginning and reads through. Now that's pretty quick for 9 rows, but if you've got 9 million rows or 90 million rows, it could take a long time. So the way most databases work is you give a table like this what's called a primary key. And in this table, it's the first column. It doesn't have to be the first column. It can also be a mix of columns. But this column is the primary key. So it's just a code for Comet. We still got Comet. Some of these have gone actually. Tiny, that was in York. They went bust. Dell for Dell, Dixon's for Dixon, that sort of thing. So if you specify the column as a primary key, what it does, it creates an index implemented as what's called a constraint. A constraint is like a rule. It constrains the data. And it effectively draws you to... No, I haven't got it on there. What you get effectively is 2 different tables. You get the table with all the data in, but you get another data table which just contains these columns and a pointer to the row where that supplier exists in the data table. A bit like an index at the back of a book. If you want to find something in the book, you go to the back of the book, you look up the words you're looking for, takes you to the page. Same thing with databases. As it says there, works in the same way as the back of a book. So the supplier table has a primary key column, so it will have an index created automatically. It's recommended that in a database, when I wrote this anyway, if it had more than 30 rows, you should have a primary key and an index. If it only had 30 rows, it didn't matter because it could read the whole table very quickly. But if it's got 300 rows or 30,000 rows, a primary key greatly reduces the time taken to retrieve information in the database. It can be a numeric key or character data, and it can also be made up of more than one field, which is called a composite key. Now if I could get that back again, if I can view connections, I can show you what I mean. On the product table, product ID is the primary key, it's character. However, on the order table, order ID is the primary key, and that's numeric. Now this one, sale line, has a composite key, A primary key uniquely identifies a row in the table. So on this table you can't use Orc ID because it's got duplicate values. You can't use product ID because there are duplicate values. There's a KB3 there, there's one there. It has a two-part key, which is order ID, product ID. And we'll see this later on, for instance, when we look at joining the tables together. Secondary indexes is another way of looking at data in the table and speeding up retrieval. So open the supplier table. Supplier table, I think the one we're using, has a secondary index on credit rating. And a secondary index, much like a primary key, speeds up retrieval. If you create a primary key, you get an index. You can create secondary indexes on all your columns. Some people do that. It slows down inserts and updates because the indexes have to be updated. But if you're only doing queries, it makes things much quicker. And the difference between a primary key and a secondary index, well, one of the main differences is a primary key has to be unique. You can only have one supplier called Dell, one supplier for Dixon's, one supplier with that code. But with a secondary index you can have non-unique keys. So you can have multiple values of A and multiple values of B. Which is what it says there, non-unique. Says there it works in the same way as a primary key. You can actually see it on the indexes tab, but because I've set it up to use views rather than tables, we don't have an indexes tag, but we will look at that later. Relationships. This one looks at relationships between tables. Now, most people are familiar with files, records and fields. You know, if you're looking at an Excel file, it's made up of records, rows, fields within the rows. The theoretical name for this is files were relations. Records are called tuples, which sometimes pops up in error messages, and fields were called attributes. We actually call it a table. This is a table made up of rows and columns. What's in a name? Shakespeare said. Now, most tables in the database have a relationship with other tables. Now, you don't have to guess what these are. If you've got a database designer working in your company, he should be able to give you a diagram like this, an entity relationship diagram, so that you can see what's in your database. They show you things like the table name, the primary key and the columns, any secondary indexes, and relationships between the tables. Now you can create that sort of thing using just bear with me a minute. I shot myself in the foot here if I can't do that with views. Let me open VirtualBox and just check that down, drop that down, thank you, go to supplier. Oh, I have shot myself in the foot, sorry about this. Okay, we can fix this. Now you can either watch me do it, or let's take a consensus. You can watch me do it, or you can log in with your own users and do it yourselves. So it probably makes sense if I gave you a user each now and you logged in using that. So I'll do that. So I'm going to post it in the chat there. So what I've come up with in one of the many windows I've accidentally opened here. Oh, don't seem to have many windows open. Okay, in zip there's a file called indexes invites, a different one. here we go. We have got you 3. So you can be those users. So if you want to do this, what you need to do is, I'll post it in there. Oh, go on, post it. There we go. Right. So Jason, you are user 20. Morris, you are user 21. Chris, you are user 22. So what you do is you go into developer. What I usually do, instead of creating from scratch, I usually change one that's already there. So I've got user 77 there. Let me drop. No, I'll leave that one there. What I would do is open user 77 and change it. So if you're 20, 21 and 22, if I'm 23, so there, I would change that to 23. I would change that to 23. And I would change that to user 23. And this is your user for the rest of the course. And then test. And if it's a success, then connect. Okay, have a go at that. See if you can switch to your new user. 23. Okay. Excellent. Okay. Okay, I need to know when you've done this, so easiest way is hands up. There we go. I've done it, my hands up. Same as the username at the moment. Sorry, I should have said. Yeah, it's the same as the username. We're going to change it in a minute. But yes, it's so if you're user 22, it's user 22. Well, if you're 21, yeah, whatever. Well, okay, forget I said that. Your password is the same as the user. It's just the easiest way to set them up. Can you do it with a little script? So if you can get in with the new user and it works, put your hand up. I mean, not like that, Morris. I meant using the software. So I can see where we are. I mean, you can give me a thumbs up as well. Sorry, Jason, I have to turn it up to listen to you. There we go, and then turn it down. Did you have a question? Yes. Just give me a minute. It's in a file. Oh, it's in the same file we just had open, actually. It's in there. So the details for connecting are there. Copy. You don't have what, Morris? No, we haven't got any views. What we've got now is tables. You don't want views was a means to an end so that you couldn't change the database. I can't see where to paste it, Jason. I'm working on it. What's it doing that for? I can't see where I pasted. Oh, it's because I'm not looking at the chat. Sorry. Idiots. I'm looking at the wrong screen. Oh no, now what's happened? Hey, there we go. Right, there's the details to connect. There you go. Yeah, that's the point, Morris. I set it up with views to make it read-only. It's the easiest way to do it. But in the real world, you want tables. So if you go into your user, I'm 23, and we'll look, there won't be any views. No, you're right. But you have proper tables. User 77 has views, but no proper tables, which makes it read-only. So go into there and have a look at the supplier table there, and it's slightly different. It's got more tabs. It's got data model. It's got constraints. It's got several more tabs along there because it's a table. The data's the same. But we can carry on with the exercise when we've done that. When I get 4 hands up. Was it 3 hands up? I can't count. Not really 4 of you. It's just Morris messing about. That's better. You can put both hands up if you want. The other one hasn't gone up yet, but I believe you. It's gone up with the first one. Okay. Let's go back, look at my connection. So what I did was took the connection there. So the username at the top, whatever you want to call it, your user there and your password, they're the same. And then you need the IP address, the port, XE, yep, and then test it. Okay. I just posted the IP address in the chat because Jason asked for it. I should have put it in the notes. God, I didn't know what it was going to be when I wrote the notes. And it might change. It work now? Oh. It's 20 to 1. Yeah? Okay. Well, no, you need a connection, otherwise you can't do the next bit. I mean, this isn't, I don't want you to leave this exercise. This is something we'll do now rather than leaving till afterwards because it makes more sense. Okay, so get your connection running, and then within that connection just click on the supplier table and you can look at the data, which is where we were back here. Same tables, and then we're here. Okay, so there's the data. What we've got now with the tables that we didn't have with the views is the model tab. If we click on the model tab, we'll get these two tables come up. And I know that the supplier table has a relationship with sale orders. So does the database, so it joins them together with this little line. Now in this particular, well, in each box you get details of the table. P means it's a primary key. An asterisk means that it's a mandatory column. So if you insert a new supply, you have to supply the supplier ID, the name and the postcode. That's the primary key, which is given a name, PK sup ID. That's the indexes. iCredit is a secondary index on the credit column, and that's the primary key. Up here you've got the same sort of thing. That's the primary key on orders. That's what's called a foreign key, which we'll look at in a minute. It's got an F on it. The asterisk is mandatory columns, and these are the keys at the bottom. You can add more columns, tables to this, but you can't. It does. I don't know how it does this actually, because there is another table link to sale order, but it doesn't show you that. Maybe if we went to sale order, actually. So it changed. Not going to change? Yeah. Oh, look at that. Now we've got 3 tables. I didn't realise we were going to do that. I wonder if we went to products, if we get 4 tables. No, that's going too far. There is a way. There are 4 tables involved here: product, sale line, sale order, and supplier. And you can draw a diagram that shows them all together, but there's another way of doing it in here. This is only showing the 3. And what we've got here is a one-to-many relationship. One supplier, many orders. And an order is made up of lines. So there's a one-to-many relationship between orders and sale lines. Now if we look at the notes, I go on to explain more about this. And about foreign keys. Now, I said that there was an F there, which is a foreign key on this table. And there's PF on here, because a field can be both a primary key and a foreign key. And this, as it says here, is the very core of relational databases, is how the tables join together. And they join together from a primary key to a foreign key. You remember when I did, if I go back to the query window for that, remember I went to the query table there, query builder, sorry, and I dragged over supplier, and then I dragged over sale order, and then I could drag over sale line, and I'll drag over product. Now this piece of software doesn't know how to join the tables together. The bit we looked at before, this is much newer piece of software. This knows how to join the tables together. This is old stuff, but it's still useful. So what you do, as we saw, is you click on these. So you want to write a query off all these tables. What you do is you say, I want the supplier's name and his postcode. I want the orders. I want the quantity ordered for each line and the product, and I want the description of the product. So you click things like that, and then when you go back to the worksheet, it's written you a query showing you all those things. Now the other thing you can do here is you can join the tables together. Now this idea that you can go from a primary key, sorry, where am I? Yes, to a foreign key. The primary key of a supplier table is supplier ID. The primary key of the order table is order ID, but it also contains sup ID. That's called a foreign key, and it gives you the ability to join the 2 tables together, like that. There's a relationship, one to many. You start, the one end is always the primary key, the many end is a foreign key. So what you're saying is that we are going to order many things from one supplier, and those orders will be made up of many lines. So on this one you've got order ID as the primary key, and the foreign key, because they can be both, and there's a link from there to there. And then the final thing is products here, which is the primary key, also links to the primary key here as the foreign key. This one's a foreign key, and you go, one product can exist on many lines. Now what you can't see from this diagram is the one-to-manys. See this diagram here, you've got the one end and the many end, the crow's foot. This doesn't do that, but it does illustrate how you can join the tables together. Now if you want to see how you do it in the yellow diagram and get all 4 of them, what you do is you go to File, Data Modeler, Export, which is I create a diagram. Hang on. No, I'll take that back. It's import a diagram. It's import a diagram from a built-in set of tables in the database called the data dictionary. The data dictionary is Oracle's own tables which contain information about all of our tables. So if you go Data Modeler, Import Data Dictionary, what you can do here is you can build your diagram. So you choose a connection first, so I'm going to do it for user 23 in the cloud, and go next. And what it does, it goes away and thinks what users there are on the database that user 23 might have access to. So there are all these users. User 23 doesn't have access to anything else. So we're going to choose user 23 there and go next. And that will bring up user 23's tables. And we can use the 4 tables, or choose the 4 tables that I know join together, which is sale line, sale order, supplier and product. I mean, if you don't know that, like I said, a designer should give you a diagram showing you how the tables join together, and he can create the diagram like this. And then you go finish. I don't know whether you're doing this or not. My advice would be do it now. But if you, I mean, you'll have the video to watch, so you don't need to. You can remember it. Where's it gone? Should have come up now. It's supposed to display the diagram. Oh, you know what I've done again? I'm useless at this. Oh no, I haven't. We're still recording. Well, I don't know what's happened there, because the password should have come up there. Sorry, the diagram should have appeared there. I think I did anything wrong with that. File, data model. Just give me a second while I run through it again. And we'll just stop. What they're supposed to do is produce a design like this, but it's not appearing. Did it appear for anybody? Hello? No? It worked for you? Oh, well done. I think that must be a glitch in developer then. I'll have a think about that, but I've not done it ever before and the diagram hasn't appeared. They've changed things around a bit. Never mind. Let's go back, and what I want to do before we finish, it's 10:02, is just finish this section. There isn't much more. Okay, just a bit of theory. The notes try and explain how this works. Like you saw there when I did the query builder, that the same column appears in different tables. In one table it's a primary key, in another table it's a foreign key. Unfortunately, in the real world, the columns don't have to have the same names. That could be SUP ID, that could be supplier ID, or something entirely different. But the way it works is, you have, oh, you can't see this. Oh, just let me change this. I like white on black, but it doesn't always show you everything that's there. The lines are black and they're not coming up. Come on. Come on. Thank you. So if we go back to having a white background, like that, and there's still no bloody lines there. Where have they gone then? That's weird. Okay. Oh, well, you get the idea from here. It says, look at these two tables. They join together. which is, you know, what relational databases are all about. And you can join lots of tables together, which Jason will see in his diagram. I'll find out why that doesn't work. So if you wanted to write a query, you know, if you wanted to write an invoice from a supplier, you'd start with the name and address, the orders, the lines on the orders, the products you've ordered, and you join the 4 tables together in a query to produce that report. That's the sort of thing we're going to do when we look at joining tables together. So these 2 tables have got similar fields. Actually, this isn't what I thought it was. This is different because I've updated it. There's the supplier table with its primary key. There's the sale order table with its foreign key. And you do a join from that table to this table. And you can see that there are multiple lines there for Dixon's, D-I-X-N. So you can join from there and see that Dixon has 2 orders. And do that sort of thing in a query. And the way you remember it is a primary key is the one end in the supplier table, and in the sale order table, order ID is the primary key, but you link to the supplier ID, which is the foreign key in that table. You know what? I think it would make more sense actually, rather than carrying on, if we stop there and I made it work. And when we do class 3, we'll start at this point. I don't know what you think. Do you think that's a good idea? I think that's a good idea. Yeah. Because I mean, it's getting late and it's theory. I might tinker with the notes as well, because I changed them slightly. There might not be as much explanation as there was before. Is that all right with you, Chris? I'm getting thumbs up from the others, but you're still hiding. I think he doesn't bother getting dressed, so he can't be on because he's got his pajamas on or something. Right, so if you want to come on the next class, Sunday night, is that okay? Oh, there he is. Hello. There's me thinking you were a big white man, you see, with hair and a cowboy hat and everything. And it's totally different. It's nice to see you. You can hide now. Okay, is Saturday night okay for you 3? For Sunday night, sorry. Yes? Jason, Sunday night. Morris, give me a thumb, Morris. Not sure what bit of your anatomy I can see there. Sunday night, okay. And you as well, Chris? Yep, okay. So we'll stop there. I'm going to stop the video now because we're done.